Hey guys, welcome back. This is section 4 of the Pendant of Performance. In this section, we'll be examining how to test the speed of your code. Very often, it's very valuable to test your current implementation with other potential implementations in order to see which provides the best performance and therefore the best user experience. So let's build a little code and then test its speed. Here we go. So remember that night constructor that we used in level 1? Well, we're going to use that again. So let's get it up here and we're going to move it down to the side. We're going to examine a very simple console method that will assess the time any code we build is going to run. Let's see how it works. So we've got a variable here called First Regiment Noobs, and that's an array of all of these guys that are about to become knights, but they're newbies: Grimble, Jark, and Bunder. And then the very next variable we have is the master list of all of the First Regiment knight objects, in which there are tons of knight objects. Next we got a loop that loops over all of the newbies, creates a new knight object with that newbie and the regiment number, and pushes the new knight object to the list of existing knights. This is the code we're going to test for time. We're going to scoot down our loop here. And right before our loop, we're going to put console.time. Yes, the console.time method will take any string and start a timer with it. You can see here that we've got time to add, and then a certain amount, and then knights. So it's going to say time to add 3 knights in this case, because First Regiment Noobs has 3 knights in it. Following the loop, we're going to use console.timeEnd, passing in the exact same string, which is key, in order to cause the timer to stop and close up. If we were to run this code now, which we did on our browser, we got the time to add the 3 knights was 0.036 milliseconds. Not very much time, right? Console.time will automatically preface the time measurement that it finds with the string that you passed in as a parameter, and it will follow that string automatically with a colon to separate the numerical portion from your label. Just to show that it would take a little bit longer time if we added a newbie to the First Regiment Noobs array, we're going to add Ernst Bread Baker over here on the back end of that array. And now when we run this code, you're going to see that the time to add 4 knights is now 0.040 milliseconds, just a little bit worse in terms of performance. One thing to notice, the string was automatically changed to 4 knights instead of 3 because we used a concatenated length inside of our time and timeEnd label parameters. As you can see, console.time is going to let us compare implementations, and that timing feature is going to help determine which code produces the best experience for either you or your users. To demonstrate console.time's usefulness in comparing implementations, we're going to get rid of this new guy variable that we declare each time in the loop. Remember, that extra declaration kind of sucks a little bit. So we're going to get rid of that guy. And we're going to scoot over our new knight call on the constructor. And then we're going to push that down into our push method. So now First Regiment Knights is pushing directly on the result of a call to the Knights constructor with no intermediate variable necessary. Kind of cool. Let's see what happens. When we run console.time, we find that we get the time to add 4 knights now is 0.029 milliseconds, slightly better than that 0.040 that we got before. Now, times are going to vary, of course, by browser, but ours was just slightly better when not using that extra variable declaration. If this process was replicated 10,000, 100,000 times, you can see that there would be probably a significant time difference that would make it very useful for your website. One important and useful feature of console.time is that you can have multiple of them run at the same time. Since timers are created and labeled by that string that you pass into the parameter, you can stack a whole bunch to produce layers and layers of time data. So let's take a look at that. We'll scoot our stuff out here to give us a little bit more space, and now we're going to add a second regiment of noobs. Yeah, there they are. Jenner, Tar, Cromer, Stem, Vorn, Rack, Bruck, and Arden are the new guys for the second regiment, and they're going to be added to this variable, the Second Regiment Knights, which holds a whole bunch of knight objects for the second regiment. What we're going to do first is we're going to start a brand new timer that's called total completion time. That's going to help us find out the entire amount of time for all of the operations we're about to produce inside this code. Both parts of our existing timer for the first regiment additions are just going to stay in place like we had them before. Then we're going to recreate that process, but this time for just second regiment noobs instead of first regiment noobs. The loop is nearly the same, the process is the same, it's just that the labels are going to be slightly different. And once those additions are done, we're going to stop that second regiment timer. Finally, at the very end, we'll just wrap up the master time with that total completion time label and a console.timeEnd. That's going to wrap up the timing of the entire operation. When we run all of this code, we get 3 different lines. The first line we get is when the very first console.timeEnd shows up, which says the time to add 4 knights was 0.031 milliseconds. Then later, we will get the time to add 8 knights is 0.063 milliseconds. Finally, we will get a total completion time of 0.324 milliseconds. That seems kind of weird. What happened? Because 0.031 and 0.063 don't add up to be 0.324. What's going on? We got to remember that setting up those timers when it's layered will also take time too. So the production of the timer itself is often included in layered timing data. Be aware of that. Not only will all of those extra layers of time measurement create a little bit of overhead in your master time data, but even running the same test over and over again will not always produce the same values. So what we're going to do here is start at the top and end at the bottom and take out all of those internal measurements for the first and second regiment, and we're going to run that test multiple times. The first time that we run it, we're going to get the total completion time of 0.069 milliseconds. But then if we run it again, you can see that that time drops a little bit. Third time, drops even more. But then on the fourth time, we're going to get more than the first time. The point here is that if we want more accuracy in our estimate, we're going to need to use the average of multiple tests. Now, console.time is a good, quick, and dirty way to just figure out how much time generally your code is taking, just to get kind of a basic estimate. But it's not going to let us have access to the numerical data that it returns in a way that would let us manipulate it mathematically. So if we want, a vastly improved accuracy in our times, and therefore our comparisons of potentially our user experience, we're going to need to take a more advanced track, and that happens in the next section. But for now, some console.time challenges, and we'll see you back real soon.